Well, hey, let's start here. Let's start with how did JP, are you from Richmond originally? How did you end up, what's your story to get to this seat?
Yeah, it's a checkered past of mistakes and learnings along the way.
When I was a kid, they called us troubled youths because they hadn't invented ADD yet. So
Right.
I wasn't super troubled. I didn't do time, but yeah. Anyway, keep going.
Yeah, well, as many people in at least the U.S. market for the data center industry, I started my life in the Navy nuclear field.
Oh, wow. Okay.
So, joined the Navy out of high school because there was no money for college, and I needed to figure out how to make some money. And I found out that, I think nuclear operators make money. I can support a family whenever I have one.
Right.
So I got to go learn a skill set that I didn't want to go into debt for college.
Mm-hmm.
And I joined the Navy nuclear program, because I found out that, hey, you can join the Navy, learn some skill sets, and then get out and have a good job.
Mm-hmm.
That good job was a senior reactor operator at a nuclear power plant. So at 17, I said, hey, I'm going to go join the Navy so I can be a senior reactor operator at a nuclear power plant. I'm going to go get all the Pokemon. Went and did that. Qualified all the watch stations you could. On the enlisted side, engineering watch supervisor, engineering duty
What does that
officer.
mean, all the watts that you can?
Oh, yeah, the watch stations. That's right. Sorry.
Yeah.
So in a nuclear power plant, it's set up in a manner and such that you operate that nuclear power plant, you produce steam. That steam will then produce the electricity for the boat. On top of that, it will also produce the electrical power and propulsions. So in order to do that, you have various different watch stations on that boat where you'll have an electrician, you'll have a mechanic, you'll have someone that checks the chemistry controls, someone that actually controls the power of the reactor itself, and that is coordinated and orchestrated by two different individuals. Typically, the senior enlisted on watch would be the engineering watch supervisor or engineering duty pay officer, or the officer in charge, which would be the engineering officer watch, or the engineering duty officer if you're shut down. So it's making sure you have a vast array, right? So it's very similar to the data centers. You're basically operating a small modular reactor underwater. I've done it for 3 years. It's an experience there, but you're effectively having a DC distribution plant with a 10,000 amp hour battery there. You have motor generator sets or solid state devices that convert AC to DC and DC to AC, all to support everything that might be on a submarine.
Right.
So starting my life off as an electrician, I had my hands in and know how to fix anything from the hand dryer all the way up to the turbine generator and everything in between. So you start your life off there, and you get those certifications along the way. Those certifications start off as we call the auxiliary electrician aft, right? You basically scrub a lot of bilges and clean a lot of carbon dust out of generators, and you work your way up. And through merit and going and getting a certification, you have to actually go to a board. You have 3 people sit there and ask you any question that you can. In the nuclear world, it's a little different, where you have to know everything from day one all the way to the end day, and you're responsible for that knowledge at all times. It's not like college where you might be able to cram for a test or something like that, pass the class, and then you never asked it again.
Right.
Every class you do, you're responsible through
Right.
and through. So that process there was learning all those certifications, so qualifying all the junior watt stations, all the way up to being able to be the senior enlisted individual, engineering watt supervisor, and engineering duty petty officer. In addition, I went and taught nuclear power for 3 years as well. And those 3 years, I also qualified engineering officer of the watch, which is the officer watch station, engineering duty officer as well, which you control the shutdown plants. Also qualified other things such as master training specialists, quality assurance supervisor. So the whole goal when you go out to sea and you go submerged, the goal is to come back up. And there's a lot of checks that you need to do to make sure that happens. So that was the nuclear Navy experience for me, about 12 years of my life, 3 of which was underwater. And that whole goal was at 17 to get those certifications so I can pick up the phone and say, hey, my name's Joshua Buzzell, and I'd like a job at the nuclear power plant. So really driven by family. I was single for the first little bit in the Navy, but then I met my wife, and it's all about family for me and how do I take care of them. So I picked up the phone and said, hey, I'd like to go work at the Beaver Valley Power Station and be a senior reactor operator. Picked up that phone, transitioned over to that space, and everything was going great, having a great time there. I was in training, enjoying that space there. And when I was 15, my mom said, hey, I'm going to move in with you when I get older. So I got out of the Navy, I bought a nice house, mother-in-law suite, and I called my mom and said, hey, Mom, it's time for you to move in. I got your mother-in-law suite, everything else like that. And she said, I'd like the age and place. I was like, well, thank you for that information.
Right.
Then about 4 months later, my wife told me she wants to be my family. I got to pick. Hardest decision I ever made in my life. To walk away for something that I'd been like training for 15 years, pushing for nuclear power. And then my wife said, hey, I need to be close to the family. So I picked up the phone and I went to the artist formerly known as Facebook. I think they call themselves Meta now. Went down. That's what got me to Richmond originally.
Because that's where your wife's family's from.
No, that's where my wife.
Oh, okay.
family's from. I grew born and raised in Northern Virginia.
Okay.
My wife's from Washington State.
Okay.
But it was getting closer to my mom.
Right.
Taking care of her, making sure she's all good to go.
Right.
But that's where I learned a lot about the data centers. Entered from the ground because that's all I knew how to learn. Was I couldn't come in. I would need to come in hands on. So came in the industry as a critical facility engineer with the intent to learn everything about everything. Made sure it was a greenfield site, level 1 through 5 commissioning. Took that over to facility operations. Did that for a few years. Then hopped over to break fix, supporting that as from a project management standpoint. And then went and got other Pokemon because I found out that water Pokemon work really great in the nuclear industry, but they don't work at a fire gym.
Right.
If I'm going to use that analogy. So I had to go get some degrees. So I went and got my undergrad in 10 months, capped that off, went and got the master's.
Wait, you started from 0 and got it in 10 months, or you had some already?
So there's some already, right?
Okay.
So like the nuclear program gets some transfer credits.
Okay.
But I did about half of it in 10 months.
Okay.
So turns out you can test out, called the CLEP program.
Oh, yeah. I know it well.
So my method was I watch a video, I take the practice test, I watch a video, take the practice test, and then in 3 days I go CLEP out the test.
Right.
My wife doesn't understand how I did it. It's
Right.
just
Your brain works how your brain works. Yeah.
the Navy and the nuclear Navy taught you a wonderful thing on you can learn anything really quickly and immediately apply. The system thinking, all of that aspect of it was really cool. And like got to serve my country, support there, but also learn a really valuable skill set, if that makes any sense.
It does. I wonder if they've bottled that where you're not necessarily applying it to SMRs on a sub or whatever, but just we talk a lot around our organization about this thing called operational maturity. So you got discipline, you've got expertise, some other things that go into it. And the model that most closely resembles that is the Navy's model. Even though we have a lot of West Point, I'm an Army guy, but the one that articulates it the best, I think all of the branches subscribe to it, but it is the Navy's idea of operational maturity. And so that's what you're describing. But I wonder if they've bottled this idea on how to train your brain to do critical thinking in a pretty quick amount of time around critical things, meaning to critical think and get the formula in your spreadsheet right. It's probably important, but to make sure those weapons that are moving through a bay or the stuff around a nuclear reactor or landing an aircraft on a ship or whatever it is, make sure, we got this right underneath a polar ice cap. It's probably important. The level of skill, not just in critical thinking, but in attention to detail, et cetera. It'd be interesting if they put that together, just like MIT will offer chemistry classes online for free or for a nominal fee. I'll have to investigate that. I don't know if they do something like that, but it'd be really cool. Or you could just enlist in the Navy. That seems a little bit more dedicated.
Yeah, I think the refiner's fire. That's I look back at my life and I think about those things, and it's just, if you lean in to challenges and you don't shy away from the work, it refines you. And if you put yourself in the positions that know that you're going to stretch and grow you, you get better. I really can't. But to your point, the bottling it up,
Yeah.
you got to have grit.
Yeah.
Like,
Well, I've heard somebody say this very, not necessarily in the technical world, but so many people, you'll see an output either of a person's life or a success or failure or something. And you'll ask them a question, same question of multiple people. You get the same answer. It's really interesting. And it goes something like this. How did you have that much success? Or how did you end up, having so much bad luck or personal decisions that went awry? And when you ask that question, they will give you, well, if you had my childhood or if you had this circumstance, you'd end up in the exact same spot. So in other words, somebody who's come from a family of profound underachievers or maybe an abuse or an addiction or whatever it is, some of the personalities in that family, I know from personal experience, react to that and say, that will never be me. I'll never be vulnerable like that. I'll never have my kids vulnerable like that. And it's going to inspire me that as hard or difficult situations come up, I'm going to embrace the suck, as they say in the SEALs, Jocko Willink says, and others, and I'm just going to embrace it. I'm going to go do it. And others, they take a different route. And I'm not trying to draw a moral conclusion. I'm just looking at what seems to be the result of this stuff. And more often than not, if you embrace the difficulty early, short of spectacularly bad luck, the outcome generally, in my personal experience, not scientific, tends to be better or clearer, and I'm more closer to attaining what I'm trying to attain than avoiding it. There's this crazy thing. I was just, not to take this probably all going to get edited, but here we go. When you see a thing that if you would just submit in obedience to the thing, whether it's a spiritual thing, whatever it is, you're more likely to get closer to the thing that you want. Whereas if you disobey, and I'm not talking about, I'll go way too deep on this, but I just know in my personal life, one short story, when I was in the military and first joined it, my orders got changed. I was supposed to go to one unit, but I was like, no, man, I went and did airborne. I went and did this other stuff. They needed, and I went and I appealed to the organization, and they changed my orders and sent me to where I thought I was originally supposed to go. I had Velcro on my stripes. I got in a lot of trouble. It was like just full-on chaos. And I'm not saying that's a story for another day. That's their fault. I ended up ultimately about 18 months later in this original unit, and it was the time of my life in the service. I'm not saying that's everybody's experience, but if I had just submitted to the program and embraced it and engaged it and tried to do all that I could be to be successful with whoever I was, the outcome, I would have avoided so much pain. And I just didn't do that. It took me a decade before I finally really embraced that idea.
Yeah, I tend to agree, right? So I think it's two things to layer onto it. I think you would just tease it out, right? It's abundance mindset, because the world is full of abundance. And if you have that growth mindset, abundance mindset, and you're willing to lean in and do the work, right, you'll become better on the other side.
Yeah.
That's why I said it was a checkered past that led me here. Just because it was not necessarily a happy path. If you're talking about programming or like that, it's a lot of things that just kept pivoting me to where I'm at right now, right? So that background in the Navy, just to get money for college, that's what paid for my bachelor's and my master's degree. I was able to do that debt-free because of the service and got the GI Bill, and then leaning in on the Oracle opportunity, director of operations, and then leading the white space.
So you left
design.
Meta, went to Oracle.
Yeah, left Meta, did Meta for 4 years, and then had a really great boss, Brian Houston.
Shout out to Brian.
Yep, shout out to Brian. But he encouraged me to keep pushing, right, and then went to Oracle, and then operations director, and then the business asked me to help scale out their design team. So I scaled out the design team, and did some pretty cool things, right? So we were able to do a standard air cooled design, standard liquid cooled design, and that in short order. The whole innovation, and it's really buckling down, grinding, and you can produce some pretty awesome things pretty short order if you're willing to be humble, be willing to take feedback, and then trust the team.
There's some smart people over there. So to be able to have, it's in my experience, it's not always common where you've got strong personalities with high intellectual people that are able to, at least external looking, find a way forward. But I know just in past conversations that that's not an uncommon experience for you. Who did you report to there in Oracle?
Yeah, so if you know Mr. Pennington.
Craig Pennington, yeah, I did a podcast with him. He is, honestly, I think I said this in the podcast too, like there's no color, shape, or design that Craig doesn't like. Like he's got this combination of British, he's very artistic minded, and sometimes he shows up with shoes and I will tease him about them. They look like they came straight off of the HR Puffin Stuff set, but I want them. I could just never... I could never sell it. There's no way on earth. But anyway, yeah, Craig, pretty smart cookie.
Yeah, so Craig Pennington, very intelligent, visionary there. Joe Walsh, Suzanne Hunter, Daniel Rohaba, like really great team there. And it was really the team, right? So if you're all willing to drop your ego at the door and collaborate and say, hey, everybody, we need to lean in and make this happen. Outside of that direct physical layer team, everybody there is amazing. And getting the support that Mahesh gave along with Clay to actually create that innovation rather rapidly, it was special, right? So it's something special that was made there, and it was, a lot of great memories and like a lot of great friendships there, right? Legacy, loyalty, and relationship, that's typically my style, right? How are you making the world better, the people better around you? How are you being honest and true with what you're doing? And then roles change, but relationships don't. Yeah. So, like, it's an amazing thing when you can do that. And it's my experience is if you leave the ego at the door and you get everybody on the table and you create a culture of innovation, inclusion, and process improvement, that's when the magic happens. Right? So, like, everything that happened there was really the team. Right, it wasn't me. Like, I had at least 50 amazing engineers working on my team directly for me, and it was really their work that did the amazing things. I just sat there and cheered them along and supported them. Like, to be honest, and then it's just the partnership with Joe Walsh's team and Craig being there, Christopher Fagiani, and then jumping over to the software side as well, like what we did with Chris Fagiani and Mertuzza. Like, that made it something really special. Amazing thing to do.
So then I'm going to want to then ask why the next thing. But before I do that, I'm really curious. What if when you and Vanessa are having this conversation, you decide I need to get near family, and there hadn't been a Meta, there hadn't been a whatever that path turned out, or your first experience was, this is not for me. I want to do something else. What do you think? Not related to this industry at all, you would have pursued with vigor down in that area?
I think it's the AI infrastructure and the Web 3.0.
Okay.
That's the next piece, I think, right? Because it's just, what's your why, right? So why I am part of what I am right now for the data center market is really how do you improve the human experience. And it's personal to me in the fact that, my mom has Meniere's disease, which if you know what it is, it's something that really messes up your inner ear, and it's really hard to hear, and it creates disorientation. She just got fitted with her new hearing aids that are finally AI enabled, and it took her from not being able to hear to hearing again and having perfect balance. Like, it brought her to tears. And that's what this infrastructure does. Whether you're putting in a breaker, you're putting in the fiber, you're setting up the cooling or buying the land, that's enabling something to improve a human experience in a way that is life-changing, right? That's the whole benefit of what we do for data centers, and like how you always improve that human experience. So for me, it's all about how do you make the world better. Web 3.0 might be a place that I might lean into eventually, but it's really right now the focus of my current skill set. It's all about trying to innovate that to enable the downstream SaaS application or software as a service application. Personal from a medical standpoint, it's cool from the fact that I get to drive my Tesla and it's self-driving. It's cool from the fact that, once again, medical things are a big thing for me. Like my wife's also hard of hearing, so I know that those hearing aids will also benefit her. And then, whatever is happening with my family, one of my kids has a genetic disorder, so like the sequencing, right? Enabling that to make sure that sequencing happens, right? I don't think I'm going to directly do it because that's not my skill set, but I can partner with the overall value chain of the SaaS,
Right.
and where I know that I'm bright,
Right.
like so that's my bright spot, and focus in your bright spot because people have maybe one or two bright spots,
Right.
like. And if you stay around your bright spot and you partner with people with other bright spots,
Right.
and you're humble enough to say, hey, you got you got really cool skill set there, let's partner.
Right.
I don't want to compete with you, I just want to partner with you. That's where the magic happens, and you have end results. Like the trickle down from the AI. I know we're talking about the big large language models and all that sort of stuff, which is important, but like the trickle down effect where it actually improves someone's life.
Yeah.
That's the whole value chain of what we're doing.
Recently, I'm not sure exactly when this podcast is going to air, a few weeks, but in the not too distant past, we had these two air tragedies. And you and I are on airplanes pretty regularly. I know I am. And I can imagine, I had a conversation with one of my daughters. And it was a little troubling, especially the one in D.C. Looks like the second one, who knows, we might have more information by the time this airs. So no investigation's been done. It's just, people are postulating, and because that's what we do, or hypothesizing rather. But on the one where you have the commercial airline coming in and you've got the military helicopter, everybody on these cockpits are experts. They've done this for a long time. The corridors that they move in are well defined. They're not unknown. You have these mitigating circumstances of night and all the other things that are going to come out. Whatever staffing looks like, whatever expertise looks like, whatever the distractions look like, in order for something like this to happen, several, even if they're incremental, tiny things, but usually it's not a thing. Could happen, but it's usually not a runaway throttle, and it just takes you up 500 feet completely unexpectedly. So when you were talking about your Tesla, for example, and AI, I'm looking forward to the day when an additional, this turns out to be just human error. I don't mean just, it usually is human error. Same thing with car crashes. We just had a fatal car crash right in the entrance to my neighborhood. So we have a busy road in front of my neighborhood. And it's head-on collision. And early indicators are somebody was a distracted driver, crossed the line, and head-on. And the consequence of that was disastrous. Like it was not just somebody lost her life, but the police. I wasn't there. One of my daughters was coming from work. Could have been right in that intersection at the time that this happened. But she had just arrived a few minutes afterwards, and the policeman said, I've been around fatal accidents, nothing like this. It was very unfortunate. And so if we can apply these tools to be part of that, if somebody's starting to get distracted or there's some unusual thing, those pilots in that case, hey, there's unusual behavior, even though it's not your responsibility, on this aircraft. Or, hey, you said you're tracking that plane, but actually you're supposed to be tracking, like something that can, just like we have lane assists or whatever, something that can help us in our ear, not in a distracting way, but in a complementary way, to give you that 1 or 2% margin that makes 1,000% difference. Like that's how I feel like we could use these tools.
Yeah, exactly. Tragic situation that happened. My heart goes out to everybody who was involved. But going back to your point is, how do you take things at scale and provide a 1 or 2% benefit?
Right.
And that will then reduce the occurrences. It's the trolley theory, right? So if you're talking about trolley theory going through,
I've never heard of trolley theory. Tell us about that.
okay, trolley theory, right? So you're coming down and like you have a track, and the trolley dilemma of you can switch. Switch one, it has two people that could get affected, or switch two has 10 people that can be affected.
Okay.
What do you pick?
Right.
And my assertion is with AI, there becomes a third option. And the overall reduction of instances like that will be reduced by utilizing those tool sets. And then there could be a third option created by AI that no one could see at that time, where it's a completely clear path and no one gets hurt.
I've never heard that term, but it was almost verbatim from Dr. Paul Root-Wolpe, who is he's just retired as director of ethics at Emory. Before that, he was the first director of ethics, as I understand it, at NASA. He's now leading their conflict resolution lab. A really cool guy, came on the podcast not long ago. And he talked about the benefit of AI. So he evaluates the ethics of, not right or wrong, but the ethics involved in biotechnology and these other things. Really cool podcast for another day. He's also got a number of TED Talks out there. But he was explaining similar scenario. I've got a autonomous vehicle, and it's something's broken or a situation, in spite of all best planning, this car is going to crash. Does it crash into the bus stop with 3 children that are unprotected, or into the bus with 60 children, but they're in a bus? How does it make the decision? If it's a human behind the car, we'll be more empathetic, according to him, if I remember this correctly, towards whatever decision they make. But if it's a machine that we've given agency to, what decision is it making? Do we agree with it? Was it the wrong algorithm? And he said, so that's one question. But the other possible benefit of AI is it perhaps chooses the third way. Yep. Do you render under Caesar what is Caesar's? Do you render under, what philosophers in our histories have been presented? Do you choose A or do you choose B? And they come up with a third way. And so you use these tools not to try to impose some great philosophical thing on them, but it's just a way. I could see a pattern and opportunity that you wouldn't normally be able to see. And so anyway, so you're attracted to being part of that.
Yeah, like that's the attraction. Like, how do you make the world better, right? So going to Oracle, the other option was be part of the program to build the nuclear reactor for the Moon project, right? Like that was the other option for me besides Oracle. I chose Oracle because I think it's just with what's being built at Oracle and those items, you can improve the human experience more than a nuclear reactor on the moon. And like that's a big deal. Like I'm not gonna say start like the moon-based projects, big deal. Making sure that it's all taken together. It's really, really big stuff. But I would rather be focusing my time on finding the third path for a hearing aid so my mom can hear her grandkids. Like that's my...
Just know you're going to come under scrutiny when your kids hit high school. And they'll be like, so you helped me, Ma, hear me, so now I can't sneak out.
Yep.
Or you could have done a nuclear reactor on the moon. My dad's failed. Wait until you're in a different place in life. But that'd be pretty funny.
Well, you also have to think what my end goal is in mind, right? Like all this work, all that sort of stuff. Like my goal when I'm 60 is I wake up, I walk outside, and I get to see my grandkids playing in the same street with me.
Right.
And that's the end goal.
Right.
How do you improve that experience where we find the third path, where we have these dilemmas that you talked about with the philosopher dilemmas that have been around for thousands of years, and there might be a third path that we're not aware of. There might be a third path on how to solve problems where there's more people win than we thought possible in the first place. They can see the abundance of the world,
right?
And you can go do that. One of my colleagues that I work with, their son is doing cloud seeding and using AI to seed clouds. They were able to dramatically increase the snowfall in Utah by one of their contracts. And that's something which you can go after as a third path, right? So all the droughts and the forest fires that are happening right now, like they're actively exploring a third path using AI to use a cheaper way to scan the clouds to see if it's more advantageous to seeding at that time, and then directing atmospheric rivers to where it's needed. That's the third path that AI
That's crazy.
opens up.
Yeah.
But in order to do that, you need to have data centers.
Yeah.
Is what it is.
Well, somebody said, so not to go too dark on that, but somebody said, well, so what's the other side of that? If you have opponents who say, we could get a advantage if our harvest is more robust than theirs. One, we'll seed our atmospheric conditions so that our crops grow better. But two, maybe we interfere with their atmospheric conditions so their crops aren't as robust. That's the other side of that coin. And so, not to be super dark, but I'm like, look, this is for me, we want to be thought leaders and lead the initiative in the various technologies that really are the differentiations, whether that's an energy or it's an AI or whatever the tools are, not just for us to flourish on our local level in the way that we've described, but to inoculate ourselves from, if I don't have to leave my borders, much less my continent, or say that differently, if I don't have to leave my continent, much less my borders, to go get energy, I have energy sovereignty. Well, now I have a lot less conflict risk in the world because we're not competing for natural resources or whatever. So if you've got tools that can help seed your environment or inoculate you from somebody else interfering with your environment, whatever it is that we're talking about, that's probably a good thing.
Yeah, I think it's a good thing. I think I go back to the two wolf analogy, right? So you have a bad wolf and a good wolf, right? It's always there in everybody. Which one wins? And the answer is the one you feed.
That's right.
So feed the world with abundance, a growth mindset.
Right.
Feed the world with a marvelous Monday, a terrific Tuesday, a wonderful Wednesday, thunderous Thursdays. There's always little clouds, and then fantastic Fridays.
T squared.
Yeah, T squared. So that's my mindset. Whereas, there's risk, but if you focus on the positive upside, I believe life has an infinite upside.
Right.
And if you focus on the infinite upside, you focus on those things, there will be enough.
Yeah.
And collectively, I have found, I haven't traveled as much as I'd like to, but everybody I've met, they want a fair shake in life. They want, their kids to, if they have them, to be more prosperous or at least have a fair chance, and that to be treated fairly. If you do that with an abundance mindset, generally it works out.
I agree. So you've had all this success at Oracle with all of this team and all this momentum. What got into your brain to say, I want to go try to solve either a different kind of problem or more focused on the problem, and now you're going over to another organization?
Yeah. So the team is amazing, right? I took that team from 5, and I personally hired everybody.
This is at Oracle.
This is at Oracle.
Yeah.
That team is absolutely amazing. I got nothing negative to say about them. Very proud of all the leaders. I personally was able to promote from within 2 managers. I was able to promote 2 people in addition to that. And they have excelled. Everyone on that team has excelled, and everybody that I was able to promote, they have excelled, and they've stepped up, and they've made amazing things happen. The challenge is that, and I agree that I helped out and supported a very interesting design for liquid cooling and air cooling, and it's the most cutting edge. When I looked into what's next, the technology doesn't exist. I decided to go to Eaton because it's the opportunity to develop the technology that's needed for the next generation design. Eaton has a full gambit of items, and they have a lot more than I think most people think. Everything but concrete they can support. in various aspects. They have they're known for breakers in the data center industry right now, but I think also the industrial component, they have a lot to offer. So imagine a place where there's next generation designs that are needed that you have, and I'm going to use the analogies that I usually use, which is the light switch in this room needs a certain amount of requirements to work and function and has a certain failure rate reliability. A switch in a aircraft has a different level of reliability.
Mm-hmm.
And that same light switch in a nuclear power plant, control plant, has a different level of reliability,
Mm-hmm.
right? If something goes awry in a nuclear power plant, that affects the area for 2,500 years.
Mm.
I'm going to take that and relate it now to the data center industry where we are in the market, where you have the Rocky market or the Rocky architecture for network that's designed for packet loss, right? Like you shoot packets down there, you're going to lose some. We're talking on a Zoom call or a Teams call, and you'll lag out a little bit, but your audio comes through,
Right.
or you start on like a robot, but it still comes through,
Right.
and nothing really happens. You can keep going on with what you're going at. Once you go to a large GPU cluster, since it's distributed computing at scale, if you lose 10% of those packets, it's 10% of the workload or 10% of the problem. You have to go back to the previous checkpoint. Even when you shift to InfiniBand, it's the same thing. We're at the point now with these clusters where they're so complex that you have to have a different level of rigor, and you have to think of it differently from a fiber aspect, a power aspect, a cooling aspect, and a land utilization aspect. And that's what I'm excited about solving now, of solving those items for, I termed it the 2P design, but what's next after liquid cooling in an aspect. And that need to create it's what's needed to push it to maybe my daughter someday walking into the doctor's office with a chip that has all of her medical data on there with the RAN design or whatever, like her genome coded, puts it into a doctor's office chip. There's an inference modular edge cluster there. It runs it. She gets custom DNA that's specifically coded for her genetic disposition that she has, and she walks back out. That's what needs to be designed for. And I don't think the technology is there yet at the physical layer to create that. So why Eaton? It's to help push that to the next level. And it's all through partnership, right? I think I'm a big thing about dropping your ego at the door and working together through partnership. And that's something that I think Oracle really taught me. Was Oracle is really great at strategic partnerships, right? I won't get into the details on it, but
Sure.
they're fantastic at strategic partnerships where hey, we've got a core competency. This other company X has a core competency. Let's partner and let's make it happen. That's what's needed to move the industry forward through strategic partnerships so that you can solve the real big problems. And getting it together, and it's, once again, Star Trek guy, so I'm going to go to that direction real quick, everybody. It's all about what's the next generation technology where, if you're listening to Star Trek Voyager, where they had the gel electronics or whatever that what is, insert, they literally in the scripts for Star Trek, they say insert technical mumbo jumbo. So I'm going to insert.
Sounds like a regular tech board meeting to me.
Yeah. So insert technical mumbo jumbo. But what I see because of my checkered past, right? So I came from operating SMRs on a distributed piece where I know what a DC distribution grid works like. I know what a battery BESS system works like. AC grids, from working my time in nuclear power from either DOD or commercial nuclear, I know how that interconnection occurs from a physical level. Going to working at Facebook, going through the level 1 through 5 designs of physical construction, taking that operational, building an A100 supercluster at Meta, going to building the first A100 supercluster at Oracle, going through the evolution of design. I have a very unique view from end to end, all the way to the SaaS layer of what's needed. And it's all about trying to get that put together as a partnership, right? And solving the most pressing thing we have is power. And power is the most, I think, everybody's aware of right now. It's been a thing for at least 2 or 3 years, but it's finally the U.S. report to Congress for the U.S.-based market has been presented, but it's happening globally as well. How do you then, now that you have that constraint, we can now talk about build your own power and the efficiencies of a local generation. We can talk about a BESS unit there. We can talk about a microgrid being a prosumer to the grid.
What's a BESS unit?
So it's a battery system that basically can provide power to shave peaking, right? So like we're going to go into the capacity market, right? So typically you'll sell in a purchase power agreement, I'm going to take 100 megawatts, and that's your peak demand typically. But in sometimes, like there's something called a capacity price for the grid where you are selling your generator as a capacity unit, and then you have peakers which will sell the peaking loads when you need something. You mentioned this on a previous podcast, I think with Chris and Christina from INL.
Okay.
They got into that a little bit, but just the piece there is sometimes you have a peak demand and you need to shave off the top 10%. Mm-hmm. And if you could just shave that top 10%, you can actually get the whole power, right? So a BESS unit would able to do that while maybe a generator set locally spins up. Right. And what it does is it increases the reliability of the system, but also reduces the overall carbon investment and fuel investment that you need overall for the system. So it additionally adds to the grid stability and the data center stability itself. So having that BESS system, having the microgrid, having your local generation opens up some really interesting opportunities on transmission, right? So what if I can get 2% of 100 megawatts, that's about 2 megawatts, that's an extra GPU block. So if I can cut out the transmission losses of 2% across those lines for a local generation, and then if there's different types of ways to distribute that possibly to be more efficient for the actual GPU unit itself, and then to think about not just the GPU unit, because that's the craze, but it's really thinking about all the different subsets of the market, CPU, storage, but to get that power more efficiently, and then think of total utilization of effectiveness or TUE concept instead of PUE, WE, power utilization effectiveness, water utilization effectiveness, but to set that up in a manner that you can then coordinate that to reduce the efficiencies, because then your fuel utilization rate goes down. And then how can you reuse that heat either through an absorption chiller or, if it's a European deployment where they're set up for piping to heat the homes, or if it's like a Idaho deployment and you're making a greenhouse. But thinking of it in that space and how to think about it differently for the 2P, right? It's not 1870. To use Peter DeBach's analogy, I won't steal it. I'll cite him. But like Peter DeBach's analogy from ARPA-E is like, hey, 1870, I'm going to make a better light, which is a better candle, right? We need to think like Tesla. How do I transmit power through the air, right? So like those are the things that we need to be thinking of, and that's the type of concept changes in order to support the current market for better power utilization, data utilization, but then to support what's going to be needed for a modular edge, where back to the conversation we were talking about, where enhancing coordination by 2%, well, maybe you need 5 microseconds of delay latency. How can you put a modular edge in cars so they can talk to each other to reduce the likelihood of crashes, that third path? How do you put that modular edge in an ER to support that? They've talked about it in 5G, but like in like real-time operations for heart surgery, right? Those critical situations where you're using that, there's going to be new technologies that are needed, thought in a different way, that don't exist right now that we have to go to. Maybe there's a lot of words, but I don't know if I'm...
Well, there's a lot tied together there. No, it makes sense. I wanted to stop you like 4 times, but I didn't want to know. You had the stream of consciousness going. My hand was cramping writing notes down here. But as you're as you've gone through that, one of the things that we were trying to do in the data center industry up to as recently as probably 2 or 3 years ago, and we're constantly have an eye towards it. How do I engineer complexity out of the system?
Mm-hmm.
And we were on that path for a while. There were conversations going on like, do all of these environments even need UPS? Do we need 1+1? Because once upon a time, we were in an availability zone or whatever. And the redundancy, the workloads were all within a building. So I would have on this side of the building, this set of infrastructure serving up a customer base. And on the other side is the redundancy. So if this side fails, the side on the other side of the building would cover it. Well, then eventually we designed the software allowed us to have 2 or 3 locations within a metropolitan area that are interconnected by WAN fiber. And so that, yeah, I'd have a workload in building A and a workload in building B. And if either A or B failed, C could carry. They were in a latency available zone. Yep. Amazon, I believe, coined the availability zone. And now over time, not in every circumstance, but in a lot of circumstances, they don't even need to be in a geographic region. Like they could be up and down the East Coast. And so if you lose a node in Atlanta or Richmond, the node in Nashville and Charlotte or Jersey City will carry it. And so the opportunity there then is, well, do I really need these generators other than a set for maintenance to stand there and not run, other than make sure they'll run for most of the year? That's a lot of stranded capital and whatever. These are the things they're thinking. And maybe a small set for a network core because they don't fail elegantly. But how can we engineer in simplicity, make it more and more like a light bulb? It could be just off, on, no consequence, no real consequence, as opposed to very sensitive. And over the last several years, and what you've just walked us through, it sounds like we're engineering back in complexity to get to this outcome. Do you think of it the same way? Because in other words, to do the things that you've talked about is not as simple as just a heat sink and a, whatever. It seems like outside looking in, the ability to deliver on infrastructure that could perhaps accomplish this promise is a more complex environment. Or is that a wrong way to think about it?
I once again, I use a lot of words, so maybe that was probably my fault. Elegance in design, I agree with. Mm-hmm. And elegance in design can be there simplistically. And you can look through that on how to remove if you understand what the actual workload is. Mm. Right? So I did a post about the data center market where people think of it as monolithic, right? Where you think everything needs to have 5 nines.
Right.
And I think what you're getting at is you don't.
You don't.
And I agree with you. So understanding the problem set and what type of load that's going to go in there and how to add in a Lego brick if you need a little bit, if you need 4 nines, add another Lego brick if you need 5 nines. But my assertion would be it can be elegant and bolt-on architecture to achieve that goal, that when you zoom out, it just looks like a couple blocks that we need to add, move around. Mm-hmm. And then you have to have the control function to talk to it, right? So like that's where the promise of AI is, where you have that control function or the neural network, whatever's going to be doing to control those blocks together so they talk nice together, then it works, right? Because if you look at a block redundant, right? 7+1 block redundant.
You're talking about UPS or something like that, or even like a RAID array or something.
Yeah. A skidded MSB design.
Okay.
Right? You're in block redundant. It's very simple. When you look at like the data center, the sub blocks of a data center, right? You have an MSB that's roughly 2.5, can be 1.5 depending on the supply chain trade-offs, that rolls in there in a skid. And then if that fails, you have a diesel backup, normally 2 to 3 megawatts, usually a little bit less than 3 megawatts, so you can put the same thing.
So hold on 1 second. I'm tracking with you 100%, but I want to make sure our audience does. So what you're talking about is we roll in a UPS infrastructure that has some number of modules. If 7 modules are what's needed for the UPS, you add an eighth. It's like if you need 4 tires for your car, you've got the spare. So you've got a 5th tire, right? It's the spare. And so when you say 7 to make 6 or 8 to make 7, whatever it is, I've got this. This is a block redundant system. Yep. So the power comes in, goes through the UPS, out the UPS to the white space or the critical infrastructure, the things making you money, doing the job.
The toaster oven.
The toaster oven. There you go. And if for some reason the grid or whatever the power supply that's supporting that UPS goes away, it will ride through for moments and it'll give you enough time to switch over to, in this description you're just giving us, a generator farm that would pick up the load that would continue to feed the UPS or whatever back out to these things. So when you say 1.5 or 2.5, we mean that in megawatts, and it's this infrastructure. Keep going. I'm tracking.
Yeah.
I'm tasting what you're cooking.
All right. We're making Pop-Tarts, actually. Right? So Pop-Tart is either down or up. It's
right.
a packet. It's a packet of delicious fruit.
Right.
Right? That's a Pop-Tart. That's what the server
Good marketing.
is, right? You have the toaster oven that heats up. You got to get the heat out, but you have to make sure there's power to that toaster oven, right? If the power goes out at your house, you've got maybe a battery wall that will take it for a certain amount of time, and then you have a generator back there. The whole thing is, why do I need a generator if I'm only going to be out of power for maybe 8 hours max? I'm just going to put a battery there.
Right.
And that's like a BESS.
Right.
Right? It's just that simple where you can break it down to like 3 or 4 different blocks and scale it as needed. But in reality, all you're doing is supporting the server, which I think was a toaster oven making Pop-Tarts. And then there's maybe another efficient way is like, how can you take that Pop-Tart and the heat from the toaster and make your coffee at the same time? And then it becomes a little bit more efficient.
Right.
Like in that space.
Right.
So to your direct question, yes, it can be elegant and it can be simplistic in design, but also increase the reliability if you understand the actual customer use case. Right? So a GPU, like a lot of the rage gets right now is the GPU liquid-cooled AI supercluster. That's getting a lot of rage in the training aspect. Eventually, and there's been some acceleration indicators in the market lately, but eventually we'll go to a training cluster that will be utilized at the end case, and then the real value add is in the application layer, and the application layer will generate value for a human or a company, and then that will help add to that.
Well, so one of the things that I love to do, and we'll link to it in the notes below, is you will post on occasion, pretty regularly, these different ideas, some of which we've already talked about. I don't know if you've teased it out a lot, but this idea of asset classes, what is that? What did you mean by that?
Yeah, so I think if you think of the value chain, right? So you have 4 different value assets in the data center industry. There's more. I understand that, but you can think of it as fiber rights, power rights, land rights, and then water rights.
Okay.
Right? And what I mean by that, like those are like the fundamental building blocks that you need as a facility owner, such as QTS, to build a data center.
Right.
And you need to, those asset classes right there, up until they're actually utilized or committed to a project, meaning like you've bought the land, the fiber, the water, and the power, and you start building, you can sell those on the open market pretty readily as like trading it back and forth. And then you get into those assets because if you don't have fiber, you're not going to be able to build a data center, which I know you've talked about and commented, which I agree that the fiber is starting to become more constraining. And power right now is the biggest issue for the industry that we need to solve in the next 2 to 3 years. Fiber is the next one. We can solve it at the same time, but don't know.
Right.
Then you have land and water utilization, depending on how you're going to use your cooling methods for that water. And that's more the asset classes. But then you go into the risk activities for the data centers. And that's when a facility owner or a vertically integrated individual will buy the land and then make a design for that, right? They go into the design of the space. If they understand what the end use case is, that's where you can make it more elegant or simplistic, where you can delete out generators. You can do a reduced gen deployment. You can add a BESS system to help that if the grid's not good enough, right? So typically how you'd reduce generators is you'd have like 4 feeds of power all independent from generators, but maybe you could add a BESS system and get that same effect with 2 feeds.
Right.
Just an example. And then you have the build phase where you actually go build it, and that's where the supply chain comes into place. Where that's a constraint where you're taking items or capacity blocks, and that's where like, hey, if I'm gonna get my breakers on time, I need that. I'm gonna get my racks on time, I need that.
Right.
So that's the risk activities where in the data centers, like in that space, that's where I think most of the capital is at risk, where you're not gonna get that ROI, or you're not gonna get it back as fast as you think you will. And then moving on to the revenue phase, right, you have ready for service. And what that means is if you're a co-location provider and you're renting a space to an end customer, they'll pay rent on that, and they'll actually pay for the power and the land and all that and those requirements, whether depending on whether it's a traditional lease or a triple net lease, that's all depending on the contract. But that's when the first revenue drip actually happens, and recurring revenue for a company actually happens. Then you go into the infrastructure as a service phase where you've loaded the data center space, typically called the white space. All that means is that's where the racks go. If you walk in with raised floor tiles, it's white because they're white tiles. That's the white space.
Yeah.
But then you load it with racks, the network gear, and you connect that, and then you can rent those racks to an end customer. And that's where, customers that are in the IaaS space might rent it to an end software as a service customer that wants to run a workload. But that's another revenue activity in that space. The last piece is software as a service. I know I've alluded to this quite a bit, but that's the only place where you're actually going to make money in the industry, and you validate the whole value chain, right? So if you think of it, software as a service is the top line. Anything that's infrastructure as a service and below that is a bottom line expense, and you have to subtract the bottom line from the top line, and then that's where you actually get the actual earned capital value. So that's what I mean by the asset classes and working through.
Right. I would love to have heard the nuclear engineer lay this out in front of the business folks. Do they, when you have this conversation with business people, do they get it? And do other engineers, how, let me say it differently. I don't often hear people that come into our business from an engineer or infrastructure, maybe is a better way to say it. They go build the thing. They go build the aircraft carrier. They know how to retrieve airplanes. They know how to make sure the logistics happen of getting the food on board or whatever. All this stuff, the operational stuff, the design, build, maintenance, and operation of it. They don't always understand how it makes money. Or they may know the mission to exert our will or to earn money or whatever, but they don't necessarily know how that happens. And sometimes they don't even know why. So when you think about this and you present this, do you also present this to your team, not just to the world? And if so, how do you help people understand? Because this is sort of if I have this perspective in my dumb army, I wasn't smart enough to work on anything. They just gave me a parachute and said, go out the door, that Huey or whatever. But our mission was almost always started off with the why. Why are we doing what we're doing? And then we built underneath that. And that way I could follow my commander's intent. I know my role in accomplishing the mission, and it was always connected to 2 things: troop welfare, mission accomplishment. And then we're out to go do something that, at least in my swim lane, supports the broader mission. And so that helped inform me between the Geneva Convention and the Uniform Code of Military Justice. This is how I go do that when I need to retreat, when I need to continue on or adjust or whatever. Do you have this conversation regularly with your infrastructure teams?
I try. I don't think it's perfect. I think it's more of an evolution as I'm learning. I'm a lifelong learner, to be honest, right? That's why I'm still in school. If you check out, I'm still learning school now. But I found that the graphic that I posted was the most thing that resonated with the group, because it was really created out of I was struggling to communicate because I could see it, but I'm how do I simplify it?
Right.
and then pull it away, because I find that if you
We'll insert the graphic in the conversation so people can see it if they want, or link to it.
yeah, that'd be good. But like, if you can talk about why we do what we do, and we can identify we're improving the human experience, that's the why. Simon Sinek says it best. I cite him, of course, but like, you start with the why. We are here, and I'll take a personal thing. So my mom can hear her grandkids.
Right.
That happens all the way out the SAS layer. And if you can walk people back to their point of where they're going, they can connect it. And then you talk to them of like, what is something you use on a regular basis to do that? The term that I told people at my team at Oracle was, what we do, or how we do it, is we design positronic brains that run the internet. That was how we did it on my team at Oracle. And what we did was we did CAD drawings, bills of material, and talked to a lot of people to coordinate that effect. And you always want to have that moonshot of, for me, building a nuclear-powered, liquid-cooled GPU supercluster. We're getting close. We're not there as an industry yet, but like, you always have to have that end moonshot goal, because that's where you're going to be in order to make it overall efficient, because there's a lot of capital being deployed. There's a lot of talk around that capital being deployed. How you then get it to a point where it's economical at the SAS layer, so then it actually gets the acceptance and penetration you need, right? So the interesting things of like the constraints in Ashburn is going to open up opportunities in other countries, because the build your own power model has been proven and tested, and then you can take it to a place where you have low reliability of power, but you have natural gas fields, right? And that opens up other populations that will be able to utilize that aspect where that technology wouldn't have existed before. So simply like skipping the grid, conversations about solar, or skipping the wires and just using cell phones, right? You know, maybe we can take the low altitude satellites in Starlink and use the 60 millisecond latency requirements to not use the fiber, and that might be a way to work around the fiber issue that you've alluded to in the past.
You know, it's a cool. So this is where my brain runs away with me, and so we won't spend too much time on this. But a couple of years ago, I was able to interview one of the lead researchers from Georgia Tech, and they were working on synthetic DNA storage. Today, BESS serve for long-term, not regularly retrieved storage, but if you wanted archival data or whatever, you'd store in this. They couldn't, at the time of that conversation, there was no better structure for storing data, no denser, more efficient in the wild and now synthetically. And so they were really intrigued by pursuing that and enhancing it. And as you were talking, what was really interesting to me was whether we do it with AI or just, the human history application, what laws exist, because we don't make these laws, we discover the laws, exist that we haven't discovered yet. I remember back in the day, 15 years ago or 18 years ago, we began hooking up DWDM infrastructure to fiber because we could multiplex the frequencies on a fiber and then add more powerful optics to it. And we just say it today, all these things. We just pick up our phone as if that's, can you imagine if Sir Isaac Newton picked that up? He'd be like, it's magic. Like, he wouldn't even know what to do with colors like that, much less all the things that it could do. Like it looks like it's perpetually powered and, whatever. Like, it's just unbelievable. And so these tools can help us discover stuff like synthetic DNA or make the synthetic DNA better or whatever. And the laws are all around us. It's like when we discovered DNA, we thought that was incredible. Then we discovered code in the DNA. That's incredible. I mean, we keep discovering these things that exist, but it's like putting on infrared goggles and you're in the same realm, but you can see things in the realm that you couldn't see before when we discovered germs or whatever. So that's what I'm excited. And some of the things that we're talking about, when it reveals things to us that have always been there to our detriment or to our benefit, that if you stop doing this or you accelerate doing that and apply this and utilize this law, Dr. Sadoway once said, I'm sure I'm going to screw it up, but basically one of the things that he hoped for or couldn't wait to see was when we could transmit power across a continent with little to no loss. He's like, I know, we don't know how to do it now, but can you imagine the possibilities if you could do that? If you could generate your power over here, where it's very low environmental impact, if any, and I could distribute it to there. In the meantime, maybe it's microgrids. In the meantime, maybe it's this other things. And I think his future state, not to put words in his mouth, would be, well, let's have it all. I got microgrids. I got long distance generation. I've got everything in between with low to no impact to the environment around me, regardless of the narratives today. What a great opportunity we should think about. And he was bullish on it. He was excited about it because he has a history of discovering these things that exist. We just don't know them. And if you can take a tool like an AI, like I thought I was a pretty good writer, and then something as silly as Grammarly, which really is an AI, but comes along, it's like, boy, you don't pay me enough to fix this. Do you even know what punctuation is? We're sending you back to 7th grade. That is not a quote. That's an apostrophe. Fix it. I was like, how did I get married to Grammarly? Now I'm getting scolded at work while I'm trying to type something. But those things, I think, really could be spectacularly beneficial to us.
Yeah, I think it opens up your blind spots. It allows you to see your blind spots from a safe space, right? Like, I love Grammarly, by the way. Ensuring that you can have your blind spots, because you only have your one view, and right, you can only focus visually, at least, on one thumbnail, right, at any time, and then the rest of it's rendered in your brain, right? So opening up that space so you can see that and then bring it to your attention to make those decisions and see it in different ways, I think that's an exciting opportunity as the industry evolves.
Yeah. Well, the cool thing about Grammarly is I'm not offended when it offers suggestions. Other people, you just stand. Can you imagine looking over your shoulder? I don't care who they are. I don't care how much you love them or how much you know they're for your flourishing. Comma, space, change that, different pronoun, different tense, different. After about 30 seconds, I know, just leave it. I want it to be like that. Whereas if it's any of these tools, I use a wide variety of them, which really can't explain then the crazy posts that I put out there. They should probably be much tighter than they are. But I find myself sometimes irritated with myself. Like, have you forgotten everything you ever learned? You do have a higher degree of education, right? Some demonstration. Well, the university wants their piece of paper back because you're not demonstrating it now. But I love these tools that look over my shoulder and help me. And more and more, you can ask them, what style do you want to converse in? And it will help you affect still accurately, but put an effect on there that you might not have any experience with. And so I just see these tools as giving us an opportunity in the same way that I can ask Waze or Google Maps or whatever, hey, my objective is to get there safely and in a certain amount of time. But the effect I might want is I want a more scenic, I want a more direct, I want to, whatever. I can apply an effect that accomplishes the mission, but I have experiences that I want to dial up while accomplishing that. And these things can make suggestions in real time, not just historical data, but in real time. That'll be pretty incredible.
Yeah, it's getting there. And that's the third path, right? When you see those things you didn't realize you knew or didn't know you didn't know.
Yeah.
Right? And that's the opportunity to keep pushing the industry forward. And that's the exciting part about, the physical layer right now on the data center, and then moving into the network layer, and then moving into the IaaS, and then finally get into a SaaS application, right? Like the opportunity of what Web 3.0 will do for us, right? People think of Bitcoin and Ethereum as a commodity or like an asset class. And I would say that it is an asset class similar to how fiber, power, land, and water is an asset class for creation of a data center. Right? So Bitcoin, Ethereum, and a couple of the other ones that are available can help you create NFTs and create the connectivity of the internet, but the authenticity of knowing that person for 30 years. Or at least knowing that they're X person and they did this contract and they signed that. That's the real, true, interesting aspect of what you can do, and then build that in that economy. And then how does that improve the human experience on top of that? Right. So there's a lot of opportunities that I know that are available.
Like what? When you think about that, so people are trying to wrap their head around this. Beyond, hopefully, Neon Cat gets up in there. I tried to roll that in as a Bitcoin idea when I presented at PTC 5 years ago. Only my solution engineer laughed out loud. Nobody else knew what I was talking about. But as you imagine this, what are some of the opportunities you think?
So there's entertainment value, which we've seen the meme coins lately, right? But I think the real thing is, what if I could give you something that your kid and only kids at that age would get, and then that would then go into every app that you have, and then you'd have to have an automatic age authentication that would be relatively cheap, and you can now know, and you look by glance, you know how old those people are. At least they went through a background check to get it.
Right.
And then you create a safe environment digitally for your children. Because right now, law is being passed about age requirements for social media.
Right.
What if you could create an environment that's safe, that that 9-year-old talking to another 9-year-old, and it's relatively verified that person's 9.
It's like the cruise ship experience. I don't know if you've done this on a cruise ship, but where you go on, you get a certain color badge, you get a certain color T-shirt, you get the certain color whatever, and if you try to pull on any of the accoutrements to say, no, I'm in the 8 to 12-year-old bucket, probably not with my full beard and my bald spot and my whatever. Like, they're able to both visually and digitally confirm you're with the right. Whether it's safe or not is a different kind of thing, but it's this first layer of, are you grouped in a way that we all agree is a way we want to group something?
Yeah, so I know through research that there's a lot of opportunity there from a value. Like, many parents will do that, but then that grows out to a lot of other business transactions, right? Like, half the time, right, we're on LinkedIn. We're both on LinkedIn. Yeah. Half the time you get reached out to people and like, yeah, sure, I'll talk to you. But like, I may or may not know you.
Right.
Like, I've gone to the conferences. I may or may not seen you at the conference before, but how do I know you?
Right.
And it's not a bad thing to meet new people, because I'm always meeting new people. But when you're trying to do things at a rapid pace, the only way that you can effectively partner are in high trust situations, right? Like if Craig calls me up and like says, "Hey, JP, I need this," I'm like, "Okay."
Right.
Like, he can call me up. And like, I know him. He knows me. He knows that if I say I'm gonna go get that done, I'm gonna go do it.
Right.
That's a high trust situation where we have work history, we know each other, and he knows that I can do certain things. I know he does certain things. If he asks for something, I'll come back and say yes or no. Or maybe this person might be able to help you out, right? And that's a relatively high trust situation. But if you're trying to move fast and you're trying to innovate, the only way to do it is in high trust.
Right.
Because the communications are shorter.
Right.
Right?
Yeah. It's interesting that you say that, because my primary role has evolved into evangelism. And every now and then I speak at a lot of places, or I listen to a lot of people a lot of places. And part of our world, just the reality of our world, is whether it's a reporter or whatever, they don't always represent themselves in a way that's clear to me. And they want to go to a high trust conversation. And, now I'm very much on guard. I haven't gotten in trouble yet, but there are a couple times I've ended up, it's different than 5 years ago, in a conversation with another, I don't mean just, but another engineer, even from a competitor, data center competitor or whatever. There's a certain level of, I come out of the solution engineering world and data centers. There's a certain level of, we go out to dinner together, a vulnerability we'll share with each other off the record. And, it's not any trade secret or anything like that, but it's how do you solve these problems? How have you thought about that? I've thought about this way or whatever. And now there's so many people coming around, and not all of them they present themselves as a white wolf, but they may not be a white wolf, or their agenda is not as apparent to me. I would love whatever those tools would be. I don't know how they'd apply in the world of evangelism, but who am I talking to? How can I either I recognize their bona fides, or they've been vouched for by somebody else, and now I give them that level or some degree of that level of trust because, the friend of my friend. It'll be cool to see.
Yeah, that's there, and it will accelerate innovation when you can do that, right? So that's the benefit of Web3 that can be utilized, and that's just one use case that I've explored. There's the other pieces of it are then how do you then create a infrastructure digitally that can then support like the metaverse. And like I know that there's been a lot of press on that, so I really don't want to get into that. But my whole thing is, in an augmented reality world, how do you then have those high trust situations, make that happen, and then you're not spending a lot of time, right, on non-abundant cycle. Right. It allows you to focus on abundant cycle, do the abundant cycle, push forward, make technology move forward, make the human experience become better. Like, otherwise, why are you doing what you do?
Right. This may not be a great example, but it's the only one that pops into mind. If you're in a military situation, military action, I'm a soldier out in the field, and I have there's a conflict, and I have reinforcements coming, and I have an enemy in front of me. This is pretty dramatic. I don't mean to be super dramatic, but I need to be very quickly validate that the person to my right and the person to my left that's coming to help me solve the problem, I can trust them with not only my life, but their field of fire, their expertise. Like I'm a combat infantry and the Ranger Bat shows up or whoever. I need to be able to validate quickly so that we can get to the high trust, what's the phrase you say, idea of
rapid innovation?
Not rapid innovation, but flourishing. What's that word I'm looking for? Benefit?
Abundance?
Abundance, thank you. Sweet mother of pearl. We're going to have to edit all of that. Grammarly, help me out. Same as Tom Cruise. But abundance, right? It's that same idea. I have people coming to join me in the mission or whatever it is. I'm trying to, it's Apollo 13. I got a group of people coming together. I need square air filters to fit in a triangle air filter, whatever it is I need. And I don't want to spend a bunch of time walking through your credentials. Are you aligned with me? Do you have the expertise? Like, how do I validate whatever we need to validate quickly so we can move to our abundance mindset together? And I think that's what you're talking about, the potential for these things to come together so that we can move in a high state of collaboration.
Yep. And that's like, so like, I think, so like Meta got you to a certain level with Facebook groups, right? I'm using Meta because I have experience there.
Sure.
I can speak a little bit to how to use
and they're
that
pioneers in that space. Yeah.
So like data center nukes. There's a Facebook group for there. There's Data Center Navy Nuke Job Finder. There's NERC Nukes, right? Which you join.
You guys love your acronyms.
Oh, yeah. Okay. So
it's okay. You don't have to explain what they are. It's okay. People can look them up. But I just love it. Whenever you talk to military and data center people, they have acronyms for the acronyms.
Yep. So nuclear operators that were in the Navy that are also in the data center space. Nuclear operators that were in the Navy and they went through the nuclear program and they basically do distribution transmission.
Right.
Or I'm in the Navy, I'm getting out and I need a job.
Right.
Right. So like that community bonding, like typically you'll know right away, okay, cool, you got it. And then like typically the last, like what were your qualifications or what you did, like in knowing that, like usually within the typical conversation with an Navy nuke back and forth within the first 5-10 minutes, like okay, you generally know what they can do and what their skill sets are.
Right.
So getting to that phase where you can actually do that in an instant or at a glance, there's valid there. There's validity there, or validity. Edit.
Yeah.
There's validity there.
Right. And if you could have your tool do it, like if you trust your tool,
Yep.
and the other tool, you know, it's no different than if I see somebody out on the data center floor. I know that they've gone through a badge reader. They've gone through physical security. They've gone through multiple security checkpoints. They've had to have different biometrics. Like all of these things just to get to their suite door or their data hall or whatever, to go through yet another layer. And so I'm not validating, are you out on the floor, unless they do some aberrant behavior.
Yep.
But if they're just doing the regular normal thing, I'm not checking it for ID because they've gone through so many checks. And I believe in those mechanisms and the tools and the safety systems. And so we're now in an abundance mindset. Like, hey, can you help me get this crash card in here because I want to do this? I'm just helping them because I believe they've been validated all the way. They have the right to this space and they have the right to this infrastructure. How can I just help them? I'm not validating that.
Exactly, right? So like we do that on a regular basis in life. But in the internet, it's very difficult to do that right now.
Yeah.
And that's where like you typically still want to meet people in person. You still want to do a lot of those things. I'm not saying go away from that, right? That's still a thing. But if we're trying to create high trust situations and high business interactions, right? Because the economy is driven by two things, a sale and a purchase. And they're always the same thing, right? So however you can create that rapid sale transaction, that's what drives an economy, right? So like if you can make those rate of purchases and make sure the money's flowing and it's flowing at a high rate, that's generally the economy's doing good because you're making multiple transactions and you're creating production, right? If you can get production going and people to make that production, or maybe an AI web agent doing the production in the future, right? So like whatever that production's doing, that's going to drive an economy. That's going to drive human benefit, and then that's what moves the energy forward. When there's a low trust situation, transactions go down. Therefore, the money doesn't flow as much. People save, and then it generally is not as good for people.
Well, it goes from abundance to austerity.
Yes.
I am way more interested. I was just going through this at our church. We're talking about if you have confidence either in your ability to replace money or in, your higher power, your God, whatever it is that they've got, like your security is in that and not these other things, you tend to be very generous. If you're not sure of that, or not just the person that you might be, would they abuse it? But you have a generous mindset if you're like, look, I've either got freedom because I'm not in debt and I've got these other things and I can just give it away, or I have high trust that I'm going to be in this abundance thing, whatever that looks like.
Yep.
I go into an austerity mindset when I'm fearful or I'm uncertain either on how it would be used or the economic whatever. And so you could just see this in human nature. I think it's not uncommon to see in the wild of things, am I storing up for winter or is it spring and I'll just, I'm not as protective.
Yeah. Are we in Hawaii?
Are we in Hawaii? Yeah, I don't know. Hey, before we spend some time, and I don't want to run out of time, but I got a couple things. You were talking earlier about modular edge.
Yeah.
My eye will twitch regularly with those two words independently, modularity and edge, because they can be defined as a million things. What do you mean by that, and why do you think we're talking? Not why do you think? Because we've been talking about. It almost reminds me of like liquid cooling. For the 20-something years I've been around, 30 years I've been around IT. Certainly 20-something years around data centers. For 18 of the 20 years, talking about liquid cooling, I think, yeah. Now, of course, obviously we're very serious about liquid cooling. Well, I've heard edge for quite a while, and I've heard modularity for quite a while. When you put those together, what do you mean, and why do you think it should be part of your conversation now?
I walk into a shopping mall and I need to have.
First of all, I just lost high trust. You go into a shopping mall, I don't believe you. Is this a virtual mall or is it a physical mall?
I don't shop anymore.
Okay, so one. And then I'm trying to think of the shopping mall in Richmond, Virginia. But anyway, go with your analogy.
I'm using an analogy.
Okay, keep going.
I walk into a shopping mall of the future. There's a modular data center in the central hub, and there's a data center modular in every shop.
Okay.
That shopping mall no longer is a typical shopping mall because I can walk into the doctor's office and I can use data that I personally own and control into a modular edge device that I can upload that data. It's utilized and then it's deleted as soon as I pull my chip out and I get the use case that I need. So I have the data privacy and controllability of my data, but I also get the benefit of an AI cluster. So as the use cases get pushed further and further to something, you're going to need to have the ability to have a data center that can be moved in and out, right? So you'll have a power block, a cooling block, and then you have that data block. Sometimes those things swap out. You have to have the ability to do it rapidly. And then you also have to modularize it because as soon as you start looking at modularization, it shrinks it. And like you can shrink it smaller and smaller and smaller, right? So I think Jensen talked about the desktop GPU cluster. Like that's an example of something that's modularized and it's on the edge that can be utilized.
We just call that a gaming laptop, but I'm tracking.
Well, yeah, when Civilization 7 comes out, I will disappear for 3 or 4 weeks.
Yeah.
But like those are the things, but like it's a different concept. Whereas like you think of a data center as typically stick built, right? And like you have to use a different name to understand the different use case. Because I go back to I posted on it like the data center market and the sub uses of those market. A modular edge is more inference, and a supercluster is usually
Training,
right? And those superclusters right now could be skidded and they could put together with a modular or something like that. But like the training cluster is really the use case, or not the training cluster, but the inference cluster is really the use case of the modular edge, along with the other data sets you may or may not need. And it's the data centers are great, right? I love QTS when I walk in.
Me too.
Yeah,
Big fan.
big fan. I walk into the facility. I see it. It's there. I walk into one of the data halls. I've got all the insert server X's there. I need that in a shopping mall. I need that inside of my donut shop. So when I walk in, it knows my favorite donuts.
Right.
And I'm using a little bit
Sure.
extremes here, but like there's things where we have not figured out yet and we don't know, but I know we're going to need some way to package that device and have that data computation closer to the point of use as data privacy becomes more prevalent and the ability to protect that data is more required from the customers, right? So like pre-Cambridge Analytica back in 2012, people cared about convenience, right? And they cared about cost, right? Post Cambridge Analytica, now we're in 2024. Data privacy and data transfer is a big deal, right? So there's a lot of leading laws coming over from Europe that are leading the way in how to control or transmit that data, so that people have the right to be forgotten. They have the privacy, or at least the anonymity in public, right? Because I'll use a U.S.-based thought process, but like typically, if you're in a closed field, open field, like if it's open out in the open, that's a public domain. And it's always been understood that like, hey, if you're out in public, no big deal. But there's a conversation here where anonymity was a right that's not written, right? So me walking down the street, like if I walk down the street and I see you, like we know each other, right? So if I do something around you, you know that. But if I walk down someone else, there's a relative expectation of anonymity.
Mm-hmm.
Being able to have all of that in the web or out in public with the data utilization, I think that's going to be a trend that possibly might happen.
Mm-hmm.
And I just look at Europe just from where that's trended so far,
Mm-hmm.
and like data transfer. So like once you get closer and closer to the data device, there's going to be either consumer demand or regulation demand that's going to require you to be able to transport that data in a certain way. We haven't fully worked it out,
Mm-hmm.
but knowing how to modularize that and then use those inferences at point of use are going to be important.
It'll be an interesting problem. On the other side of that,
Mm-hmm.
I have no dog in this fight.
Yep.
On the other side of that, on the one hand, my wife has terrible knees. We're trying to get them fixed. Bone on bone. She's petite, little, half Japanese, half Irish girl. I am not petite at all. I have no knee problems, even having fallen out of aircraft many, many, many times. And so she's got her handicap sticker, and she wants to park right in front of the imaginary mall or wherever we're going. I'm fine parking in the garage. Like, where is it safe and easy, and I got to walk a block, or, I'd be more inclined to put in a moving sidewalk than me having to contend with the congestion. Now at the Atlanta airport, I never park at the airport parking lot that I used to right up next to the thing because it's too hit or miss. I park at the one that when I pull in, it reads my license plate. It's got 7 floors, and as I pull into the thing, it tells me what floor has available spot. Like, it directs me to the thing. There's elevators and escalators everywhere. Is it 8 minutes further? Sure. It's got moving sidewalks. It's got a train that comes and picks me. Like, it's so convenient. I don't have to remember a credit card. It just scans my license plate, bills the corporation, et cetera, et cetera. So I'm wondering, what am I gaining or losing? It feels like I'm possibly losing efficiency if I have all of these edge nodes wherever they are instead of a central node. So if I've got a big data center in an Atlanta metro area, for example, and I have terminals out throughout all of these other places, well, now I'm just trying to secure that link. If I'm bringing my thing physically with me and I don't physically have it as opposed to an app, I lose it. It's well, there's the encryption on it. How's that encryption any stronger or any better than a connectivity? Like, I feel like that those are the things. What do I gain from efficiency? Because for 3.5 million people, this 1 million square foot facility is the edge, certainly with some things, as opposed to having dozens or multiple dozens of these stations wherever they may be. It feels more secure going into a bank lobby to have a money handling transaction than an ATM. Mm-hmm. Maybe not in every case. Probably the most secure ATMs are in the bank lobby, but now it's even more secure. Like, it's on my phone. It's got to do facial and finger recognition, and then I enter my pass key, and that's as secure as anything else and convenient. So as we sort through these things, that's where the benefit of the edge, that has to be a real, a transaction that happens right there, less because of more because of speed than anything else, or latency or whatever. So that seems like I've yet to solve. I've always been, where's the work happen, and can I do it within latency constraints? And should we be working on the encryption of protecting the data between points as opposed to extending more points that they themselves, those physical points, could become more vulnerable, just like that ATM could be more vulnerable?
No, it's a fair conversation, and that's where the use case is going to determine that. Right? There's use cases that do not yet exist. I think that's my biggest assertion here.
Okay.
Is like, there's use cases that do not yet exist that we will need it for.
Yeah.
And ensuring that you have a modularization for that can scale will be useful in the future. But to your point, you just mentioned speed as what is most important to you, right? So with the consumers that the speed is the most important, then absolutely, I agree with you. And like, there's going to be also like power utilization. I'm not going to pay, $90 a flop for this thing, right? Like, it just doesn't it's not viable unless it's like that flop needs to be very secure for a very specific reason, but that's going to be not necessarily mass market.
Right.
And it's ensuring that you know where those things are.
Right.
So, yeah, like latency is also going to be another issue where like, hey, we've done all these training clusters. Can we break them back up and make them inferences now? And where we don't require the latency, we're not going to have them out there.
Yeah.
Right? You just don't need them. There's other use cases where there might be a need for that.
Yeah. I heard one that was really cool by our buddy Tony Grayson. He's over at Compass. But he's in their modular division.
Yep.
Does a lot of DoD stuff and other things. Posts about that all the time on LinkedIn. He was talking about their new designs, how synthetic they are, how light these things are. You can deploy them with the C-130 or whatever, back of a truck, super easy. And we got kicking around this idea years ago. I wrote an article about farming and how the single biggest risk to small farms isn't big corporate farms, at least at the time of that article. It was none of their kids want to be farmers. Like, why would they? And one of the largest producers of robotics on earth is John Deere. But they don't have the connectivity and the things that they need to have those harvesters or the drones or whatever, or the robots out there. They've got people eager to learn technology, but they just don't have the they didn't have a Starlink. They don't have anything like that out there. Now, those are all being solved. But Tony and I were kicking around this idea when we were at PTC. He's like, can you imagine deploying light, easy, fast, highly secure? You could build your own little microgrid in them through a variety of ways. Solar works great there. There are other things that work great because they've solved these in combat situations and other remote, hardened situations. But you can deploy this here, connect it to your technology. So many ways you benefit a local farm or agriculture or whatever. There's other micro uses of it. He doesn't see it as a competition between big or little data centers. He just sees it as a mesh. These purpose fit, they go do these things. They get deployed this way. It was fascinating. And then my imagination caught a hold of me, and I've had to spend more time than I care in the Build-A-Bear shop. And I could just imagine having one of these right there, latency sensitive, helping me design in 3D my Build-A-Bear. And I think that would be a spectacular use of a edge data center, modular edge data center this for sure will get edited out because who wants to see me with Build-A-Bear, but it's pretty cool.
I like Build-A-Bear. My kids, I got three daughters and a boy, so yes.
My girls made me, they create these things that you can record into because they wanted, as a Christmas present, my wife's voice and my voice. I don't know why. And they said, you go pick out the Build-A-Bear that you like. It's a gift for us. Mm-hmm. And then we want your voice recorded for all posterity and stick that in there. So, yeah, I'm not going to reveal what my Build-A-Bear was, but I have a local data center help me solve that. That'd be a great use of technology.
Yeah, so I think the other piece is like the unconnected, right? So once you have that modular solution,
mm-hmm.
drop in deploying that easily in the Caribbean or APAC, where there's a lot of micro communities, right? Less than 10,000 people that need a data center, or it's high tourist destination area, right? If you go to Cancun and you're sitting there waiting for the payment transaction for 5 minutes to go through, would you rather just have the same connectivity as now? And if you have that modular solution that's set up to be an edge cluster that has more ruggedness, and I like Tony, and you brought Tony up, so I'll bring up his work there, and like he's got a lot of good work there,
right?
And like taking that ruggedized solution that's okay with extreme climates, that you don't have to have as many techs hit that space,
right?
You drop and deploy that. You can have someone drive around, maybe check this data center once a month, and you can go through that. But what you got is when you're out there in Cayman Islands or wherever, you have faster transactions, and then you can keep just enjoying the experience. Yeah.
He would probably be wildly offended if I said this. That's okay. I love Tony anyway. But like I could see it on a cruise ship. We did a Alaskan cruise, my family and I, early summer last year. And I didn't need connectivity very often, but I needed it sometimes. It was terrible. All the other things about the experience were great, but it was terrible. So to have something that's rugged and robust and interchangeable on that boat or whatever, data centers could be a variety of sizes, but be able to survive the rigors. Like when you leave the boat, I'm sure you don't. I mean, you were just in submarines, so you don't know real rigor is like. But these boats, they go through something. I'm here to tell you. And they would open up the cargo doors where they bring on the food or whatever. And just imagine it's like a typical regular warehouse, and they're really rigorous. Like I was impressed with their process, but you're 3 feet above the ocean. So you've got all of those environments. You got to bring the gear in, whether it's blustery or hot or wet or whatever's going on. And so electronic gear, I have to keep reminding my family that computers in the cloud really aren't in water vapor. But to be able to deploy if that becomes important, a modular thing in there that is robust. Yeah, you're not taking bullets, but in all the other physically secure, electronically secure, robust from a power feed or whatever. There's just so many ways these things could be deployed. I could see them happening easily.
Yeah, but going back to your point, like there has to be a commercial value,
right?
Well, like in the end of the day, someone's gonna be willing to pay for it, and the SaaS app has to add enough value to justify the whole stack.
Yeah.
And like that's the challenge oftentimes is like, okay, well, is there a value there? Can you see that value? And that I think will be maybe a limiter, right, for adoption, right? The data center industry loves new technology, 10 years old.
That's right. Thank you, Peter Gross. Yeah.
Yes.
Yeah.
And like that is the piece that, the adoption rate, right? We were talking about liquid cooling for, 30 years in the industry. And now it's actually becoming a thing, supposedly. Right. I've heard rumors.
Yeah.
And that,
you may have been an architect in those rumors, but keep going.
Heard rumors. But that's becoming a thing. And like the DDC, the direct-to-chip liquid cooling became the most prevalent, right? There was a lot of immersion conversations that was going to happen, two-phase, but really it was the direct-to-chip single phase is what took off. And it could have gone any way. All of them were available. It's just like that was the most commercially viable at the time. So like having those things ready to go, or at least like 70% products ready to pivot in any direction and be ready to add the dry powder whenever you need it, when it's the moment of impact. I think that's going to be key to just listen to the markets.
So we've been talking for a minute.
Yeah.
This is going to have to be I was going to do a two-parter, but we're not. It's okay. Our bladders have made it this far. Everybody can hang out for a few more minutes. We'll have bookmarks. They can skip to the parts they want, but I got a couple less questions. Early in our conversation, and interestingly enough, with Craig on another day, we spent a lot of time about collaboration, transparency, and we've touched on that to one degree or the other throughout this entire conversation. If you think about it as an industry, one of the things that I loved when I talked to Craig was, and I think he was being the most generous, like you're on a conversation like this, and it's a public, and so I get sometimes the more specific conversation about how things may or may not be working in the marketplace. Like he doesn't talk about who they're a customer of or how it works in deployment, but it's a small world, so we have these conversations. So I don't want to get into that in the micro, but at the macro, one of the things that he advocates for regularly is, look, as a customer of a lot of data center companies, I'm able to have these cross-pollinated conversations. And there are times, whether it's a supplier or it's the owner-operator, so infrastructure that's going into a data center to help me serve up my infrastructure, or it's the data center design, build, operator, whatever, or even my own team, he would say, within there. There are times, because of his position, he can force conversations. He's like, no. This is not how we're going to do it. Everybody come into the room. We're all under NDA or whatever. We're opening the kimono so we can solve these problems. So his polite public thing is we're going to collaborate. But there is a forcing mechanism that he would apply, and not unexpected from any of the big hyperscale customers to make that happen. But if you think about it as an industry, like How do you imagine getting, outside of that very specific application, the various mechanical groups or electrical groups? Like, we don't have a lot of standards. We have standards within a very narrow vertical, how we move electrons or molecules or whatever. We always have talk about regulations coming, and we don't want regulation imposed upon this industry, or regulation that we're going to regret, maybe is a better way. I'm all for regulation. But how do you imagine at a higher level, not just I'm your customer, you're my customer, or whatever in that business relationship, but within our industry, is there an ability to have some level of transparency and collaboration? How do we make that happen? Or is that much more difficult?
I think in my last place, it was a lot easier to drive it.
But you're in an ecosystem. How would you get the frenemies of your last place to cooperate?
So I think it's I go back to legacy, loyalty, and relationship, right? So I really believe that people want to make the world better, right? I think everybody wants to work together to make a result that's going to be mutually beneficial. There's some groups that, in fundamental dynamics of the industry, that I don't think are well understood, in my opinion. And I think it's also because it's shifted probably in the last 12 months. So the collaboration is needed, and you can do that by merely picking up the phone and calling them, right? So I won't use names, but even in this new position I'm in, I've been able to pick up a phone and say, hey, can we work together again? And he's like, yeah, absolutely, let's do it. And that's more like on a use case basis, but you're trying to zoom out a little bit further. So I'm getting to that. You have this application layer uses software to do a thing. The only thing they care about is how many tokens they get a second, right? The token being the data bit that's been crunched inside a GPU or CPU. There's only 4 or 5 manufacturers that make chips that are currently relevant in the industry. So you have the chip class, making sure you understand what the SAS class needs. And having that intimacy to understand those two things are key. And then that can cascade through to the rest of the groups, right? So then you have the integrated customer class. You have a IaaS class of customers, right? AWS, Oracle could be considered that in some cases. They're hybrids, of course. Sometimes they're a SaaS class customer too. And then you have the colo class, right? Like the colo class of group. And then you then have fiber, power, land, and water, right? So that's more government regulation, that piece. But understanding that those groups and class exist and coordinating to make that happen. I like Open Compute Project. That's good. I think that's the best thing we have right now. But I think we need to drive more of that through actual conversations in a true conference, right? So I think love Data Center World, love Yada, love Supercompute, PTC, of course. Getting a academic conference, I think, is what we probably really need outside of a sales conference. And I don't mean that any way. You need to go, you have to evangelize your products and whatnot, but there needs to be like a true academic conference. The closest thing I've seen is what Peter DeBach's been doing through the RPE program. It has been useful. But to get to that true collaboration through mutual benefit, that's the difficult part when it comes down to a commercial relationship. But understanding what the SaaS class customer wants from the chip class provider, that's where the dominant signals are. And then from that, you can reinvent the rest of the design. That's my opinion. I don't know what your thoughts are.
I completely agree. I love the idea that the next part, so that solves the not solve, but it gives us an opportunity within the, so as you're talking, I'm imagining scientists talking about in the 20s and 30s, the benefit of antibiotics and a penicillin and a whatever. not the groups that are going to go sell it to the marketplace, not the groups that are going to have to fund it, but the scientists talking about what is it, how does it work, how do we iterate, how do we share across labs, how do we do that, and like in genuine, which happens regularly, in genuine or archaeology or genealogy, all these other things where you get to, and ego and other things are involved, but you get to see them more often than not. You see this collaboration and papers written and cross-pollination. It's absolutely fascinating. So I love that aspect. I love that idea of I'd love to listen in. They probably wouldn't let somebody like me in there, but just to listen to the conversations would be incredible. The reason why I suppose the other part of that, the second part of this question for me is up until probably 3 years ago, I didn't have to go to communities and try to persuade them on the value, micro, modular, large, whatever, of a data center. First of all, they probably didn't even know it was there or what it did. It was all, don't tell anybody we're in here, even though we're going to wear a T-shirt with our company's name and have purple mohawks and have it all catered in, whatever. But now there's some misinformation about either the value or the risk or the benefit of this industry and what it's doing. Not all of it unfair, a lot of it exaggerated. And so a lot of us, especially when you're a world of introverts, having to learn how to articulate in a non-engineering way, no acronyms, no logic steps or diagrams, but be able to connect like you did, I thought beautifully, not talking about SaaS or any of those other things. These tools enable something like this device for my mom, my kid's grandmother, and this is how it's changed her life for the better. Does that make sense to you?
Yeah.
But you would say that to somebody, really, you could do that? Or this car, when you have a car that has the ability to do these things, and for example, some of you, I was just reading about, you ever heard of the Marshall Tucker Band?
No.
So they wrote a song. They're from South Carolina from the 70s. It's probably way before your time, but they wrote a very famous Southern rock. They sort of invented the Southern rock genre with a song called Can't You See? And just weirdly, I was reading about them last night. And the one brother died in like April in a car crash, 25 years old, hit a dump truck, I think. A month later, his other brother, all members are related to this band, died in a car crash in another unusual circumstance. And then the third brother, the original guitarist and songwriter and sometimes singer, died a few years later. And I'm imagining if you had a technology, whether it was tracking health of the last brother or helping your vehicle traverse, whether you're distracted or enabled or whatever the circle, or just predicting, things going on, and you could articulate to that family how a technology could help enhance the life of your kids, or an EpiPen or whatever, however we could apply these things. When we have the ability to tell this story and also confront misinformation, whether it's related to water or power or whatever, I think that back to collaboration and transparency and conversation, it's part of the whole thing, not just how do the academics get together, which I love that idea. I've never thought about that. The frenemies that are within an industry to make sure that it's represented well and it's real governance is introduced and we adhere to the governance. And then we have the ability to communicate the value chain, the result of that SaaS, to a group of people and how it can help them flourish.
Yeah, no, I love it. I appreciate the tack back to the community, because it's all about the community at the end of the day, right? So ensuring that those communities also know that there's an opportunity for jobs.
Yeah.
Right? And it's not just someone going to college.
Right.
Right? I didn't go to college until I was 35.
Yeah.
Just
certainly not with that attitude.
No, not with that attitude at all, right? And I say that because there's past the happiness where we need master craftsmen, right? And my wife's family are master craftsmen, right? So, and the fact that, they're carpenters, drywallers, but when you go in to see their work, It's like the Sistine Chapel
Right.
type deal. And whenever like I'm in the field talking to teams, it's, listen, you're making the Sistine Chapel of fiber, right? This fiber is a positronic brain, and there's an elegance and a beauty to what you're making. And understand and respect what you're creating, because it's part of the tapestry, and it connects from like the craftsmanship level to the community, where an 18-year-old individual who graduates high school can go work and learn skill trades, right? But it's going to take a personal touch, right? Individual people, person-to-person conversations to drive that. I understand there's going to be more holistic and, announcements and PR campaigns for that. But like, will really change a life, and you really change a thought process. It's one-to-one, heart to heart. Like you never, any other way, you're not going to do it.
Right.
And like, how do you help out? Like, for example, I live in outside of Richmond, over in New Kent, a very up-and-coming place for data centers, and talking to the local high school leaders there is like, hey, there's people who can go, they're good with their hands and they can go work right away. If you know how to use a drill, use a tape measure, and a hammer, they've got a job for you.
Right. Or you're willing to learn. Like, you've got the aptitude to learn. You got the attitude and the aptitude. We'll get you the basic skills pretty darn quick.
Yeah, it's things like that. Like, so going back to how to like collaborate as a group, right? You have to have like, I guess, the academic piece. You have to have the aspect of a community involvement, but then how do you come together as a community to say, hey, we want this? And I think it's the multiple dimensions, right? Industry partners, and like, listen, like I always tell people this, we can always be friends, right? Like you might work at a different company. We might be competitors right now, but we can always be friends and work together to further the industry. And like to say that with community leaders, you always be friends, right? You might not agree with this item, but Loudoun County has about $2,000 to $3,000 lower taxes a year compared to Fairfax County and Prince William County because of the data centers. Yeah, like things like that where you can connect. Right. And if you can connect what's valuable to that person and how we can mutually benefit, I think that's where we can get to that collaboration piece, because that's what breaks down the barriers. It's going back to the authenticity. If you know how we can have a high trust conversation and connect, right? So if they know that, and we can educate them appropriately, and they can educate us as an industry of what's important to them, and maybe there's something we can pivot. It's a two-way street on that.
Yeah, I agree. I think the bummer there is, and Buddy Reiser and I have talked about that as well, for the longest time. Well, I'll just say it different. There was an opportunity for us to come in. I don't even think we recognized the need and say, hey, we're here to bring this value, doing it this way, and engage in a real, not just an economic way, but in a real community way, in every way. One day they woke up to headlines and they saw a bunch of trees getting cut down, not realizing that those acres were always intended to be commercial infrastructure, always. It might have taken 30 years instead of 5, but it always was intended to do that. And to stand there and, I don't know that it was QTS, but as an industry person, as an introverted engineer, not to pick on them, when that conversation first came up, you're like, what are you complaining about? That's always going to be, like, we're just going with the logical fact, not the, hold on, you got surprised. Okay. What is it that's surprising you? Let me help. Okay, let me help first understand and then have an actual conversation. Got it. And perhaps there is something that we could have done different or adjust or whatever. But in that first blush, because it was the first anywhere really, these buildings are ugly buildings. And they're supposed to, for the longest time, nobody wanted anything but gray buildings. I guarantee you my CEO, who loves color, wanted our name and color on anything and everything. When you come into one of our buildings, there is no doubt you're in one of our buildings for a variety of reasons. But it wasn't a deliberate, like, just be quiet, we know what we're doing, ever. It just was, I think that all of a sudden one day when everybody sort of woke up, what's going on, we weren't prepared we weren't well prepared as an industry. Maybe some organizations better prepared than others. I remember listening to Meta and Google talk about this once upon a time years ago, coming into an industry, and all of a sudden they had concern, whether it's from an app or whatever they were doing, and they had to learn how to do real community engagement, not just lip service, not casual, but actually get involved. And they've done a pretty good job, in a lot of us in the industry are learning from that as well, and just leading with transparency, taking our lumps. But I really do think whatever else we talk about technology is as important as anything else. How do I make this personal? How do I get belly to belly? You can't build community, it's static. It has to be personal, and that can be messy. But to get down and get involved, I really think that's the only way. In addition to the technology that we're evolving, that's the only way we're going to be able to continue to grow.
Yeah. Do you know Wes from Nova Data Centers?
I may.
Yeah. So I think he owns Nova Data Centers. He started that. And if you walk into one of his data centers or just drive up to it, it's architectural in nature. You walk in and you've got a presence in there that's more welcoming to the community. There's things that he does to ensure that, like, it's more people driving by will be proud to work there, or they make a community center near it, or like work with the community in that aspect. I think that's more the piece. I'm not saying QTS doesn't do it. It's just that's just one, because I had a conversation with him. I had dinner with him a couple months back, and it was just talking through that aspect of what his mindset associated with it. And I think that we're not too late is my point.
Right.
Right? Like we can still do that as a community.
Yeah. So we've talked a lot. Before we wrap up today, what do you want to make sure you leave us with?
Yeah, I think that the two key points is, as a community in the data centers, we need to start thinking of total utilization effectiveness. So thinking from how's the community affect us, but also the whole power conversation all the way down to the flop. And once we do that and start thinking more in those broad terms and not necessarily just with POE, power utilization effectiveness, or water utilization effectiveness, we can start driving the needle to where we need to go. And driving that needle will allow us to truly innovate, like Tesla or Edison has innovated, and get to the point where we can make more hearing aids for people so their grandma can hear their children.
Right.
Or find that third path.
Right. I love it. I have a question on that, though. So my buddy Dean Nelson has been on here. He's talked about this as well. And I said, Dean, when you were a leader at Sun or Uber or some of the other places you've been at, if somebody like me, an operator, came and said, hey, look, I don't want to have this kind of resiliency in the system. So while I could have a good PUE, I might not have a great TUE. So I want to tighten it up so I get a better TUE. And he would say, absolutely, at that time, absolutely not. I need this margin built in because this engineering group or whatever, for whatever reason. So I couldn't, there wasn't a forcing function there. Now, flip that. And I think it was Christian Bellotti, I might have that wrong, from at the time Microsoft introduced the idea of PUE, but wherever it came from, an imprecise, imperfect, but a start, right? And a lot of people, especially an organization like ours, that started off with brownfield, there was no PUE in mind. And so to begin measuring and reporting, and it was, I'll be generous and say a 3, and get that down to a 1.6 in some of these environments, a 1.4 in other environments. Not in our greenfield designs, but in those designs is incredible. But the reason why that pivoted, not just for me, but for the whole industry, is our customers said, if you want to do business with us, I need to not just see a path or a philosophy. I need to see architecture that's going to get me there. And I need to be measured and reported in this way and blah, 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 all these other things. So how do you think we could get to an adoption of a TUE if the customers of operators don't require it as part of the solution? we could talk about it philosophically, but if we don't actually have a mechanism or requirement by which to get there, how do we get there?
I don't think we're going to have to go there because the purchase of power agreements won't be signed.
So that's a forcing function. I mean, that's what would happen.
Yeah, so I think there's a lot of signal from Europe right now on the current regulation and the reporting metrics that are required there. And then I think getting the actual PPAs in the U.S. are starting to have that conversation where if we take it a holistic approach, that will be a better sell case. And where it's the public-private partnerships where you have the regulated or non-regulated markets, knowing to have that will actually get you your power. And then bringing in the other pieces of the end customer, possibly requiring it. But I think if you can provide to a customer value of your cost per flop being lower, they'll be able to put more GPUs in that space. It'll be a natural piece if you can provide that value to the customer. Outside of Europe and or EMEA markets and the Americas markets, it's still coming to the APAC markets too. And getting that PUE or really the TUE where it needs to be to get the cost per flop down opens up other markets. So there's a lot of value as those markets develop. So to summarize, I think it leads to more innovation, and that innovation allows us to unlock more potential for improving the human experience.
Well, I think that's a great place for us to end this. I'm all about improving the human experience. Yeah. JP, thanks for coming on the show today.
Thanks for having me.
My great pleasure. Hey, if you liked that, click the like button. And if you loved it, click the subscribe button. See you next time, everybody. Have a good one.